66. All right, so we have a logarithmic function. Your basic logarithmic function looks like this. F of x equals log base b of x. Okay? And because the parent function has a b in it, just like exponentials, we're going to have an infinite amount of parent functions, and they just change depending on whatever your base is, but they're all basically, it's all basically the same idea. So if we can do one, we can do them all. So it says a logarithmic function is the inverse of an exponential function. So logarithmic inverse of exponential. Then it says using your graphing calculator, nope, we're going to use our brains instead, sketch the following graphs. Okay, so let's talk about how they are inverses. This is basically y equals log base what? 10 of x. And if I wanted to rewrite this in exponential form, like was just on your quiz, the base is 10. This would be 10 to the y power equals x, right? This right here is y equals 10 to the x. See how they're inverses? X and y switch places, right? That's what makes it an inverse. So algebraically, the x and y switch places. Graphically, it's a reflection of the line y equals x. So we're going to graph the log based on what we know about exponentials and how to graph that. So this exponential, I have an asymptote. Where would my asymptote be for this exponential function? 0. Oh, x or y? Y equals 0 because it's horizontal. Okay, so I got y equals 0 there. And then, so when x is 0, y is 1. When x is 1, y is 10. And when x is negative 1, y is 1/10. Something like this. Okay. All right, so if these two are inverses of each other, then when x and y switch places, my asymptote that is at y equals 0 becomes an asymptote at x equals 0. So for a log, we have a vertical asymptote at 0. Then we'll go through each of our points here. At a point when x was 1, y is 10. So it's 1/10, so that changes to 10/1. About right there. This point is at 0, 1. That changes to 1, 0. This point is at negative 1, 1/10. So that changes to 1/10, negative 1. So my graph looks something like this, which again is just a reflection in the line y equals x. So we're going to use our knowledge of exponentials to graph all of our logs, okay? Because knowing what 10 to some power is way better in your brain than knowing what the log of some number is. You're not expected to necessarily know that. You are expected to be able to figure it out given, depending on what the number is, okay? So, and that's what I think this says. To graph logarithmic function, you can use the inverse exponential function, then invert the values. All right, so let me show you what we're going to do with that. So usually we come up with our anchor points and we just say what they are and we put our pencil there. We're going to need to write some stuff down. Because we're using the inverse and we're switching things, the numbers are not going to be difficult to find, but which means that it's going to be very easy to mix it up in your brain. So you need to write it down so you don't do it backwards on the graph, basically. So we have this. There are no transformations here. So my function, my parent function from this is just y equals log base 1/2 of x. Basically, it is its parent function because there's no transformations. So then the first thing we want to do is rewrite this in exponential form. My base is 1/2, so this would be 1/2 to the y power equals x. Okay, so we are used to substituting something in for x and getting a y out. That's going to be very difficult in this because y is in the exponent. So instead, we're going to substitute stuff in for y, get an x out. What we substitute in for y in the parent function is going to be the exact same every single time. So we're going to make our little x and y t-chart here. So for y, we're going to substitute in negative 1, 0, and 1 every single time. That's what's going to get you your anchor points. So 1/2 to the negative 1 power is going to be 2. 1/2 to the 0 power is 1. 1/2 to the first power is 1/2. So like I said, coming up with what those are, that's going to be a piece of cake every time, but have it written down so you don't do it backwards. All right, then we would talk about transformations, but there aren't any here. So now we're going to graph this. I have a vertical asymptote, and the parent function, it starts at x equals 0. What's the only thing that's going to affect where that vertical asymptote is? Oosh. What's it called? Translation, good, or horizontal shift, good. So do I have a horizontal translation here? No, so that means I just have a vertical asymptote at x equals 0. Then I find my anchor points and then do transformations, but like I said, there's no transformations here, so I just find my anchor points. So I'm going to go to 2, -1, I have a point there. I go to 1, 0, and I go to 1/2, 1. My graph looks like this. Okay. What questions we got? Now, if you look at this compared to this one here, this was log base 10, so the base was greater than 1. Here's when the base is less than 1 but greater than 0. Just get some steps in. Yes. And so it just looks like a reflection in the x-axis, kind of like the exponentials with this one's increasing, this one's decreasing, that sort of thing. All right, so my domain, where does the domain start? 0, and it goes to infinity, right? My range starts where? -infinity and goes to infinity. Good. So what my domain clearly can change, right? Depending on where my asymptote is. Would you agree with that? Is there anything that we can do to this that'll change my range? No, it's going to be the same. So kind of like with exponential, your domain is always -infinity to infinity, but the range changes depend on the asymptote. So now that we've switched x and y, those two facts switch right there. Okay, my x-intercept, that's something I have there. That's 1, 0. My asymptote is at x equals or y equals? X equals, so it's x equals 0. Then as I move to the right, x is approaching infinity. And as x approaches infinity, f of x approaches -infinity. And then we move to the left, is x approaching -infinity? No, what's it approaching? 0. Then f of x approaches infinity, okay? But we have to be a little bit more specific than that, so we're going to go back up here for a second, right up here where we have some space. I can have x approaching something other than infinity, right? Some number, in that case it was 0, but let's just say that number, some number is a. But I don't approach it from both sides. I was approaching that from the right, so I would put a little plus sign up here, and that would read x approaches a from the right. Okay. Or I could have that x approaches a from the left, and that would be like the exponent. Where an exponent goes, it's not an exponent, but where an exponent goes, you would either have a plus sign or a minus sign, depending on whether you were approaching it from the right or the left. So all this is as x approaches, and that would be from the left. Okay. All right, so let's go back to here. And x is approaching 0 from the right, so I need to put a little plus sign here. Okay? Because remember, just because you're approaching an asymptote, depending on which direction you're approaching it from, you could go in different directions. You could either be going, maybe both sides are going to infinity, but maybe we have togetherness, maybe we don't, depending on the graph. Okay. Everybody okay with all that? Okay, so let's try, one with some transformations. So the first thing I want to do is now look at what's going on with my I have transformations here, but this one, if I have something in front of x, I don't get to do my A, B, C, D transformations like we've been doing forever unless this is factored out of whatever this is. So I need to rewrite this. This is going to be y equals negative log base 2 of negative and then x minus 2. Whether it's just a sign or it's a number or it's both, it has to be factored out of what's inside of there for my transformations to work like we know them. Okay. All right, so then I figure out what my parent function is. My parent function is y equals log base 2 of x. Because the 2 is not a transformation, that's the base of the log. Then I rewrite this in exponential form. The base is 2, so this becomes 2 to the y power equals x. And then I get x and I get y. So for y, we substitute the same thing in every time. -1, 0, and 1. 2 to the -1 power is 1/2. 2 to the 0 power is 1. 2 to the first is 2. So again, never going to be difficult to fill out that little t-table, but you need to do it so you don't get things backwards. Because if you refuse to do it, I promise you at some point something's going to go wrong on your graph. Just because you're used to thinking the other way so much, it's hard to make that shift. Okay, so then I need to write down what my transformations are. I start off with this negative right here. That means that's a reflection. Reflection in which axis? X. Okay. Then I move along here. 2 is the base. That's not a transformation. Then I have this negative. That's also a reflection in what? Y-axis. So if I got those backwards on this one, it wouldn't really matter, right? I get lucky. And then that 2 means that I go right 2. All right, so my asymptote. I have a vertical asymptote at x equals what? 2, right? Because I moved to the right 2. Does that make sense? So I'm here at x equals 2. Now, these points here are not points that I plot. They are my anchor points. It's where I start. Then I do my transformation. So I'm going to go to 1/2 -1. I'm starting right here. And then I reflect in the x-axis, so I end up here. Then I reflect in the y-axis, so I end up over here. Then I move to the right 2, and I end up right here. Okay? So let me do that again. I started at 1/2 -1. I was right here. I reflected in the x-axis, ended up right here. Reflected in the y-axis, ended up right here, moved to the right 2. Then my next one is at 1, 0. Reflect in the x-axis, I don't go anywhere. Reflect in the y-axis, I end up over here, move to the right 2. I'm right back where I started. That happens sometimes. Then I have 2, 1. I start right here. Reflect in the x-axis, I end up right here. Reflect in the y-axis, I end up over here. Move to the right 2, I end up right here. Okay, so before I draw my graph in, if I've done transformations, I want to double check because the x-intercept is something I need. If I don't already have it graphed, I want to go find it before I graph it in case it can help me with my curve. But I have it, so I'm good. I can go ahead and sketch this in. Looks something like this. So my domain, where does my domain start? -infinity. And I go to 2. My range is -infinity to infinity. My x-intercept, 1, 0. I don't get to guess off the graph. Asymptote x equals 2. All right, as I move to the right, x is approaching 2 from which direction? The left, so it's a negative. Then f of x is approaching infinity. As x approaches -infinity, f of x is approaching -infinity. What questions do you have? We good? All right. Let's look at the next one. All right, so again, I'm going to have to factor this out. So this is going to give me y equals 2 times log base 4 of 1/2 times x plus what? What is 3 divided by 1/2? 6. 6. Not 3 halves. That's 1/2 times 3. 3 divided by 1/2 gives you 6. And then we have minus 3 right here. Because if I distribute that 1/2 back in there, I got to get 1/2 x plus 3. All right, so there it is factored out. Now I find my parent function, y equals log base 4 of x. Then I rewrite it in exponential form, 4 to the y power equals x. Get my anchor points. Y, I substitute in negative 1, 0, and 1. That'll give me 1/4, 1, and 4. Then I am going to talk about my transformations. This 2 is a what? Stretch. It's a vertical stretch by 2. Okay, I move along. The 4 is part of the parent function. It's not a transformation. That 1/2 is a horizontal what? Stretch by 2 also. The 6 means I go left 6. 3 means I go down 3. So I'm going to put in my asymptote. Where is your asymptote? Y equals negative 6. Right. Then I'm going to start with my anchor points. I start at 1/4, negative 1, so I'm starting right here. Vertical stretch by 2 makes my y value negative 2. Horizontal stretch by 2, my x value is currently 1/4. I multiply by 2, I get 1/2, so I didn't go that far. Then I move to left 6, 1, 2, 3, 4, 5, 6, and down 1, 2, 3, and I end up right about there. Then I'm going to go to 1, 0. Vertical stretch by 2, nothing happens. Horizontal stretch by 2, my new x value is 2. I move to the left 6 and down 3. And end up right there. Then I go to 4, 1. I start right here. Vertical stretch by 2, my new y value is 2. Horizontal stretch by 2, my new x value is 8. Then I move to the left 6 and down 3. End up right there. But before I sketch it in, I do not have my x-intercept. So I need to go figure that out so I can plot it over here and it will affect my graph a little bit better. So if I want to find my x-intercept, an x-intercept occurs when? When y equals 0. So I substitute 0 for y. So I get 0 equals, and I can just use the original one, 2 times log base 4 of 1/2 x plus 3 minus 3. Okay? So my goal is to get x by itself. I'm going to start by adding 3 to both sides. So I get 3 equals 2 times log base 4 of 1/2 x plus 3. Okay, so then I need to take care of that 2. I have 2 options. That 2 could become an exponent. Would you agree with that? Okay, but I could also just divide by 2 right here, right? So I think I'd rather divide by 2 than try and have an exponent like that. So this is going to give me 3/2. That's equal to log base 4 of 1/2 x plus 3. Okay, so now I have a single log, and I can rewrite this in exponential form. So my base is 4, right? So I'm going to have 4 to the 3/2 power equals 1/2 x plus 3. So I need to take care of that 4 to the 3/2 power. 3/2 power is the same as 1/2 power times 3. So what's the 1/2 times 3 power? I said that wrong. So what's 4 to the 1/2 power? 2. And then I cube it and I get 8. So 4 to the 3/2 power is just 8. So I get 8 equals 1/2 x plus 3. So I get 5 equals 1/2 x, and x equals 10. So your x-intercept is 10, 0. So I can go over here to 10, 2, 4, 6, 10, 0. So I've got that point right there. then I can sketch this in. Looks something like that. Then my domain, where does my domain start? -6. So we're going from -6 to infinity. Range is still -infinity to infinity. Asymptote is at x equals what? -6. All right, as we move to the right, what is x approaching? Infinity. And as x approaches infinity, f of x approaches infinity. As we move to the left, what is x approaching? -6 from the right. Good. And then f of x, when that happens, f of x is approaching -infinity. What questions you got? Anything? All right, so then we're going to skip down to number 8. I'm going to go, I know I'm not going to be able to finish this in any class, so we're going to do part of number 8, and then for the video, I'm going to finish 8 and do 7, and then if you need to go back and watch them to know what's going on, you can just fast forward to the end if you've already seen this. Okay, so let's look at this. What's my base here? E. The base is E. I don't need to factor anything out, so I can just say my parent function is natural log of x. So when I rewrite this, I get e to the y power equals x, because my base is e. Make my little t-chart here. -1, 0, and 1. That is for my parent function. That is where I'm substituting it in. So e to the -1 power is about what? 0.4. E to the 0 is 1. E to the first is about 2.7. Okay, easy enough? All right, so those are my anchor points. The first thing I want to graph, though, is, well, actually, I take that back. I'm getting ahead of myself. We need to figure out our transformations. That 3 is a what? Vertical stretch. Good. It's a vertical stretch by 3. Then the 1 means I go down 1. Okay? All right. So now my asymptote is where? Where's my vertical asymptote? It's vertical. The only thing that affects it is going left or right, and I didn't go left or right. Okay. So then I'm going to plot my points. I start with 0.4, -1. Then I have a vertical stretch by 3. My new y value is -3. And then I move down 1, so I'm about right here. My next point is at 1, 0. Vertical stretch by 3, nothing happens. But then I go down 1, I end up right there. Then I go to about 2.71. Vertical stretch by 3, my new y value is 3. And I go down 1, I end up about right there. Okay, my x-intercept, not plotted. Okay, so I need to go figure out what that is. So I can say 0 equals 3 times the natural log of x minus 1. So I'm going to add 1 to both sides, and I get 1 equals 3 times the natural log of x. Again, that could become an exponent, but I can also just divide by 3. So I get 1/3, and that's equal to the natural log of x. Now that I have the log by itself, I can rewrite it. The base is e, so that gives me e to the 1/3 power equals x. All right. Do you have any idea what e to the 1/3 power is? That didn't help me graph-wise. But this graph's different than the other, where I'm going to probably hit pretty close to where it goes anyway. I did find it, so let's go ahead and write it. E to the 1/3, comma 0. All right, so I have nothing else to graph. I can sketch that in. All right, so now that I've graphed it, give me a ballpark estimate for what e to the 1/3 power is. About 1.5? Would you agree with that? I'm getting that from the graph, not from any knowledge of what e to the 1/3 power actually is. Like, I'm not doing crazy number stuff in my head. I'm getting that from the graph. Okay? We good? What questions you got? All right, so you can fill in the rest of this. Like I said, I will, on my conference period, I will come and restart the video and finish this and do number 7 so that you can go back and complete those if you need a better understanding. If you've got enough of it, then you've got enough of it and you're good to go. Okay? We good? All right, so I'm going to finish up number 8, and then I will go back up there and do number 7. So my domain starts at 0, so we're going from 0 to infinity. My range is still negative infinity to infinity. I have a vertical asymptote at x equals 0. As I move to the right, x approaches infinity and f of x approaches infinity. As I move to the left, x is approaching 0 from the right-hand side, and f of x is approaching negative infinity. All right, so let's go up and do number 7. All right, so on this one, I don't have anything to factor out. There's a negative there, but there's not 2 terms, so I'm good. So my parent function, y equals log base 1/2 of x, which makes my exponential 1/2 to the y power equals x. My x and y here. -1, 0, and 1. X is, let's see, when I substitute in -1, 1/2 to the -1 power is 2. To the 0 power is 1. To the first power is 1/2. All right, then my transformations, let's see, I've got nothing till I get here, so that is a reflection in the y-axis. And then the 3 means I go up 3. So I didn't go left or right any, which means here is my vertical asymptote. My anchor points, I'm going to start with 2, -1. I reflect in the y-axis, so I end up over here. Then I go up 1, 2, 3. Then I go to 1, 0, reflect in the y-axis, go up 1, 2, 3. Then I go to 1/2, 1, reflect in the y-axis, go up 1, 2, 3. Okay, so I have an x-intercept over here. Don't know what it is, so I need to go and find that. So x-intercept is when y is 0. So 0 equals log base 1/2 of negative x plus 3. So I'll subtract 3 from both sides. Get -3 equals log base 1/2 of negative x. Now I have a single log by itself. I can rewrite it. 1/2 to the -3 power equals negative x. So 1/2 with that negative power makes it a 2. 2 cubed is 8. So I get 8 equals negative x. So x equals -8. So x, equals -8. So I have -8, 0. So now I can plot that point here at -8. And I can sketch in my curve. My domain starts at negative infinity and it goes to 0. My range is negative infinity to infinity. Asymptote is at x equals 0. As we move to the right, x is approaching 0 from the left. And when that happens, f of x is approaching infinity. And then as we go to the left, x is approaching negative infinity. F of x also approaches negative infinity. Okay, and there you go.